Okay guys, I'm going to start this one. Let's see today's agenda. So we are going from beginner to intermediate today. So we'll start with very basic, like what's Docker, and we'll see what is Docker registry, and then we'll see how to write a simple Docker file, and then we'll see how we can simply push Docker images, and after that we'll see how we can optimize Docker file in various ways, and same goes for secure Docker files. So let's start with what is Docker. So basically these are the official statements here. So Docker basically is a open platform for developing, shipping and running applications, and we see client server architecture here. So client talk to the Docker daemon, and Docker daemon do all the things including building, running, distributing Docker container, and Docker daemon basically talks to registry, whatever Docker registry we logged in or we have the credential on our Docker daemon host. Here you can see, and then we'll see what is Docker registry. Okay, so Docker registry is nothing, just a storage and distribution system where we can simply store our Docker images, where we can share to the world, right? And we have two kind of visibilities of registries. One is public, like the third-party companies actually manage those all the infrastructure, such as Docker Hub. We have Amazon Container Registry, and we have Google and Azure. And there is one more which we call it private registries. It is for isolating our what we call it registry from the internet and use it internally. So we generally host it on premises or VPC, and we have the options here like Harbor, GitLab Container Registry and JFrog Artifactory. Okay, so let's move on and see how to write a Docker file. Okay, so here we have a very simple Docker file for Golang. So we can see all these statements. I will go through a brief of each statement here. So we'll start with the from. So basically we start our Docker file from from statement, which we call it as base or parent image, and then we have working directory. We simply use it to set our current working directory, and then we say whatever the content we have on our host and we want to move it on Docker container. So we use copy command to paste them into the container. You can see we just moving those two files, go mod and go sum, into the current working directory as we set here. And then we say run command. Run command is nothing, just running the Linux commands. You can say go mod download, it will download all the dependencies. And again we're using copy because we want all our code here into the container. And after that we building our binary as a executable. So we can see we just building that to do executable here, and this expose statement exposes our services to the host. We call it 8080 right now at the moment, so we just saying expose 8080 port. And on entry point we say like whenever we try to run our container out of this Docker file, so it will run as a executable. So it will simply run this to do. So we can see we have a to do at the bin folder, so it means it will run as a executable. So any questions so far regarding any these statements, or any previous about the previous slides? So I will take silent as no, right? Okay.
Yeah, sorry.
Yeah, yeah, Satish.
Yeah, so the from statement is there, right? The from command, let's say, I mean, generally the purpose, to run the images in any of the OS, right? So that's the purpose we create the Docker file, right? Be it Ubuntu or Windows or Mac.
Yes, yes. So basically, yeah,
So
exactly. So
let's
it is independent from host basically.
uh, okay, let's say if I don't mention the OS, so in that case what will happen? Let's say if I don't mention the OS and I'm trying to run the trying to build the image in any, I mean, let's say I'm trying to build the image in the window, so then how it works?
So basically, this all managed by your Docker engine, right? So whenever you install on your
Okay.
Mac or any operating system, that will be managed by that only. So we don't have to worry
Okay.
about any command whatever we're running here. It will simply run over there. And
Okay.
we have basically right now we can use Windows images as well. So it totally depends on what kind of base image we using. So we generally using Linux, but we got to see that we have Windows base images as well. So where we can run Windows specific commands as well. Is that okay to you, Satish? Or like
Yeah,
if
okay. So if I run, let's say, if I run this Docker file, if I just trying to create this Docker file in let's say in a Windows system. So again, that depend. I mean, what I understood is, so that Windows dependency, whatever required, will be taken care by that image itself, or by the Docker engine itself.
yes, yes. So that will be taken care by the Docker engine itself. So yeah,
Okay, so we know not to mention explicitly,
no, no,
right?
no.
Okay, fine. Yeah, thanks. I'm good.
Hi, Sunny.
Yeah, hi, Vijay.
So in the Docker file, what is the difference between run command and entry point? Like for those three, what is the difference between those three?
Okay, so this run command will run when we build while building the images. Okay, so because we have two stages, right? One is when we're building the Docker image, and one is when we're running the container out of that image, right? So you can
Okay.
say run will be there for while building, okay, and entry point will run when we run our container.
Uh, Run, okay. Entry point, can you say it once again? Like a bit
Okay,
confused.
so let's say right now this is the Docker file here, but we want to make it as a package. So what we will do is simply build it, right? So it will create image, right, out of
Yes.
this Docker file. So while building, these all command will run. Okay, this run statement will run, but this entry point will not run while building. Okay, it will only work when we run container,
Okay. Okay. So
right?
once it after build, then only entry point will work.
Yes, when we try to run the container from this
Okay.
image.
So what about the command CMD? CMD is there, right?
Yes, both CMD and entry point work as it is, but there is like couple of difference. Like entry point make our container l- work like a executable, right? So like if we don't pass any command to container, so it will simply will work, right? And command cmd also do the same thing, right? So
Okay.
it will run as it is when we try to run the container.
Okay. And a single Docker file contain how many commands or entry points? Like we can use
So
multiple or only one?
basically the last one, let's say we have couple of there, like we define here, but last one will override all the above one. So last one cmd or entry point will be taken as a primary execution point.
Okay.
Yeah, so all I mean, like if you define n number of time, it will not matter it because it will take the last one only. Right. Yeah. So any other questions?
Can we read a host environment variable to the Docker file when we build
So,
for
sorry,
application naming purpose?
sorry, Vijay, I couldn't hear you properly. Can you?
Hello?
Yeah, yeah,
Hello?
yeah.
Yeah.
There's some noise.
So,
Yeah.
yeah, once. So, my question is, can we read a host environment variable when we are building our Docker image into the container that time?
Okay.
So, this question is for my purpose is for giving the application naming based on prod, stage, and UAT.
Okay, so basically we pass, when running Docker run command, so we simply pass the environment variable over there. So basically we know that Docker containers are isolate, right? So it will not, see what is going on host. So we have to explicitly tell Docker container what are the environments variables are there. So that's why we use docker run hyphen e, uh, argument there, and we pass all the uh, environment variable there.
Or I can say, can we use one image for different environment servers like prod and all for the like, can container read host environment variable
Okay,
from
so
inside?
wait a second. So I'm just trying to wait a second.
Because I want to use only one image for all.
So you want to just want to pass the docker environments, right?
Other question like I have one image,
Okay.
Docker image, okay,
Okay.
and I want to use that particular image to all environments like prod, stage, and UAT.
Yes.
But application name should be different based on the servers. Like if one server is staging server, so
Okay.
application name it should take text from the host
Yes.
environment variable
So basically,
from inside the container.
yeah, for all different stages, we're going to use different environment variables, right?
Yeah.
So that's the thing which will be different in all of the uh, what we call it stages, right? So in that case, what we can do is we can simply pass, when we run docker run command, and then say uh, e, and we say, let's say, stage. So we pass like this one to any container while running it. So this way we can pass a number of things, or if we want to pass in the docker file, we can use env. uh,
So is it possible when we do release from an CI/CD tool
yes, yes. So
without manual intervention?
yeah, so like in CI/CD, we can simply pass this way as well, right? So
Okay.
we can simply say write a command over there, and simply take it dev or any value from CI/CD specific environment variable, right?
Yeah. Okay. Got it.
Yeah. Okay.
I,
So
I want to add few points here. So
yeah.
I think as you are running these commands, either it can be in Bash or in a Windows environment.
Mm-hmm.
Uh, so as you are working in a some directory and you copying some file from your code to this working directory at copy command. Similarly, you can have your environment variables as well. So I think you can also will be able to pick those environment directly from file as well. Just you need to do some tweaks for your commands basically.
Yeah.
So all you are doing here is running your bash commands here, right?
Mm-hmm.
Simply you run these commands in console as well, for
Yeah.
example. The same
Yeah.
thing you can pick based on whatever the environment variable you have. I mean, like different variables for dev, staging, QA, and your production. Same way you can conditional picking up values here. And also coming to the CI/CD pipelines, they segregate these things in their UI or in the code as well. You can segregate from your a different file. So I think that can be taken care. Just need some tweaks and experiments.
Okay.
Yeah. So
Thanks.
okay, so let's give a little demo here about building image and see how we can push it to our registry, right? So at the moment we have our Docker file here. I'm going to use this particular Docker file for this demonstration. Okay, so you can see this Docker file here, right? And let's build it. I'm going to give it tag and the context. Okay, so it just quickly build because I already built that, so I'm using caching. So we'll come to the caching later, and we'll see this one. Okay, so right now my registry is at this point, right? So first I need to tag it as it is. So what I will do, I will simply tag this newly built image, sorry, okay, so you can see this particular tagged image here, which is same as it is mine repo address. Okay, so I'm going to push this one to okay, so it will quickly push that to our repo. Okay, so meanwhile we'll go ahead and we'll see how to optimize it. Okay, so we write Docker file, but I guess that is not the enough one, because we see a lot of time that our Docker image size go like large files, right? As a large files, like sometimes it go for 1 GB, when it sometimes it go 1.5, etc, etc. So how we can optimize that basically? So we have some ways to do so. First is Docker layers. We can utilize the Docker layers and its caching, and second one we can use multi-stage builds, and third is of course we can ignore all the files, just like we have git ignore and we have docker ignore file as well, so we can utilize that as well. So let's see Docker layer first and try to put some light on it. So we can see, so these layers are generated when commands in Docker file are executed during the Docker image build. So we're just building our image, right? So we can see the history of that this one. So we can see the layers here, right? So each layer itself is an image. Okay, so we can see this is there, and we say user, setting the user, right? And then we have other one which is entry point, setting the entry point, and then we have expose, and each command is creating a layer. There is one more thing, like these layers are immutable, so we cannot change it. But when we run Docker container, it simply add one more layer on it which is mutable, so we can change that. So we can see let's go from top to bottom, and we can utilize Docker caching here. So we need to be a little careful when we write such things. Let's say when we writing copy go mod and go sum, so we can see which is less frequent changing layers, because the rules are here the caching validation will work from top to bottom. So let's say if something change on layer 3, right? So the following layers 2 and 1 will be invalidate. So once we run it next time, it will rerun those commands again. So I can show you this as well. So you just see these all building commands, and it's using our cache, right? You can say it's using the cache, right? Because nothing changed. So Docker says if no layer changes, utilize the previous cache from host. But what if something get changed? So if I say here, okay, so here's the code basically. So let's say if I add one more package here, just like we do for Node.js or any other programming language. So we say we just added one more package. So what will happen? We just change this layer, right? Because next time when we try to build it, Docker will compare from the previous build and to the current build, and see like we added or removed any package. So it will say, okay, discard all the following layers because this has changed, and these below layers will be dependent on this layer, right? So that's why the thumb rule is put all the less frequent changes above, or we call it top, and then copy something like frequent changing below, right? So adding a new codes, it's quite frequent than adding new package, right? So whenever we change some code, it will discard the below one, which is not like it will take much time. It will be very quick for us. So I can simply show you a quick demo on that as well. Let's say if I go and let's say for the middleware, if I change something in code simply, so like instead of task, if I say simply task, right? So we just change this layer, right? We just change this layer. So if we try to run the docker build command again, sorry, so what we'll see, you can see, so after this copy command, we can see it not utilizing the cache, right? Because we just changed this one. So as we know that if something change in one layer, the following layer will be invalidate. So it will build those commands from the scratch again. So always remember that, always put frequent change on the top and less frequent change on the top, and frequent changes the below. Any question regarding this one? Okay, so shall I move on, or any question?
Yeah, let's go ahead.
Okay, cool. Okay, so this was the Docker layer, and this Docker layer will simply reduce the build time. So Docker layer we simply use for reducing the build time. What about the size now? Okay, so we'll see multi-stage build. We have a single Docker file, but we define multiple base image to utilize. Okay, so let me go to the code and show you. So we can see on line number 2 and line number 13 we utilizing two different base image here. Okay, so why is that so? Because let's say for the stage build, right, where we're building our executable files, we require all the uh, uh, packages or dependencies there. So we say, okay, for the building executable, utilize this heavy stretch base image. Okay, but when it comes to release, go to release and simply utilizing which the Debian image, which has very less installed software there, or services running over there. And then we say we want some build from our first stage. Okay, because in first stage we build our executable and that we want to utilize. Okay, so for utilizing that same thing we say copy from build. So we name first stage as a build and second as a release. So if you want to copy anything from the previous build stage, you simply ask for it name, we call it from build, and at this particular path we said we build our executable. Now on the second release we want that executable. So what we say, we want that path and where we want that executable in this particular stage. So we do so and we copy it from there, and we can see we left all these packaged installed in first build, right? And we utilize this one because this particular image do not have any privilege escalation tool, sudo and su like that, and it do not have even bash shells as well. So it is very lightweight. So we just said copy the executable from there to here is this particular release, and it will drastically reduce the size as well, because we just trim our size by moving to the release. So we can see this change here as well. So if I'll see Docker image we just built, and we can see the size as well, right? So we just built this particular sorry for that to app. Okay, here it is. We can see this particular image here. I can build that again later. Sorry for that, because I built from test. Okay, so I can show you images there. Okay, so we can see the current size here, right, which is 939 MB, which we use for this one because we haven't used the multi-stage build. Okay, so this is size when we are not using multi-stage build. But what happened when we utilize this one? Okay, so let me build it again with, I guess we already had that. Okay, so okay, so we have this particular version as well. So we can see that this reduced the size to 34 MB. That's it. So we can say we just moved what is required to the other stage. We can simply see. right? So this way we can have n number of stages, and we can simply keep on trimming those unnecessary files, and we can utilize the final stage as our main image, as a base image, we can say, from where we will create the container. So any question on this one? Anyone? No? Okay. Okay, so we see in Docker layer, we see multi-stage build. Now we're going to see dockerignore, which is pretty simple. So there are few things in which ways we can write our dockerignore file. We say if you want to ignore any particular file or folder, you just simply name it on that dockerignore file. And here we have this dockerignore, just named it docker file because I don't want to move docker file itself into that container, right? So here the thing. Now if you want to ignore directories within sub directory name modules, let's say, right? So we simply say modules out there, right? So anything which is inside that module directory will be ignored. It will not copy the container, or we call it image. And next is, if you want to files which start with modules, so we simply use modules asterisk, just like the regular expressions. And if you want to ignore one level down from the current context where we actually running our image, so simply say from the current root directory, whatever the modules folders are there, one level down, it will simply ignore that as well. But what if it has n numbers of levels down? So what we'll do, we simply say asterisk asterisk / and modules. So it will simply ignore all the modules files wherever it is in current context. And the last one is like ignoring everything, right? Entire build context, we can simply say asterisk. So any question on this dockerignore?
I think all good people. You can participate here. If no question, you can say no, so
Hello.
that he can. He's doing one-sided. No, it's not good.
Hello.
Let's participate to the event, so that he also feels like okay, the people are understanding here, are with
Hello,
us.
Saurabh.
Yeah, Vijay.
So this dockerignore will use in Docker file, or after the like in while running the Docker file we can use, or any else somewhere we can use this dockerignore.
Basically we can use it anywhere where we actually pointing our context. So here while building the image, so we said dot here, so we saying the current directory as a context. So we can see we have docker file, and we have dot ignore file at the same time, right, in the same context. So we need to put that in that context basically,
Okay, got it,
right?
sure, thank you.
Yep. Okay, so no questions so far, right? Okay, moving ahead. So now we seen how to optimize in 3 ways. Let's see how to secure docker files. Okay, so the first one is like running the container as non-root users, and the second one is content trust in Docker. So where we say verifying the publisher, and the third one is scanning the image. So let's see the non-root user. Okay, so we seen this in our Docker file already. While copying, that executable or to do executable, we say changing the ownership. Okay, so we says user ID 1001, right? So 1001 we call it, and we say the group ID will be 0. But there is a few notes we need to know, like administrative users are from 0 to 99, okay, which are added during installation process. So we should not use these numbers which falls under this range. So that's why we use 1001s, okay. And then, but maybe we can wonder like why we using 0 group ID, because you can say the kernel do not give any special permission to group 0, so we can basically utilize this 0. So now this to do has this ownership, so it will not able to do any kernel specific thing or any root privilege things it cannot do. So this is one way we can secure it. Any questions regarding this non-root user?
All good, I
Um,
guess.
yeah, sir. Hi, sir.
Yes, sir.
Yeah.
So mostly while running the containers or any Docker commands, we don't prefer as root user, right? So we'll mostly use non-root only. Like we don't run Docker commands or anything with as a root user, right?
Yeah. So basically, when we copy any file to our uh, what we call it into the container, it will go as a root as well, because it goes for 0 colon 0. So we need to explicitly tell it कि do not use 0 user ID. Otherwise,
Okay.
in
So we
that
have to.
user, in that container itself, it will run as a ownership with the
Okay.
ownership of root user.
Okay. So we have to specifically mention that don't go for root user and like that.
Yes, exactly.
Okay. Yeah, got it.
Okay. Any other questions regarding this non-root user? Okay. I'm moving ahead. Okay. Now the next topic is Docker Content Trust. So basically, Docker Container Trust provide the ability to use the digital signature for the data sent to and received from remote Docker registries. Okay, so this will verify the integrity and the publisher of Docker data provided by the registry. So we can see the image record here basically. So we see Docker registry host colon registry port. If the registry is self-hosted, then and we have different port, then only we specify that. Otherwise, if it is on port 80, so we don't need to specify that. And we have / and we say repository and tag. So DCT is associated with tag portion. Okay, so it will sign that tag only. So we generate set of keys that image publisher used to sign an image tag. Okay, so there's one note on Notary server, because Notary server is tool basically which comes inbuilt with Docker Hub. So we don't have to worry about if you're using Docker Hub, but if we actually hosting our own Docker registry, just like Harbor or any other GitLab registry, so there we might have to install Notary server and configure it. But if you're using Docker Hub, we don't have to, because they already did that for us. So we can say it's a tool for publishing and managing trusted collection of the content. So basically it will signing and verifying those things. So how notary server is working. So a publisher can sign their content offline, okay, using keys which they can kept in highly secure storage, or and then they can push when they feel okay, I want to push that signed content to the notary server. And consumers like us, like if you want to use any content from notary server, because we want trust on that particular content, so we use publishers public key through a secure channel, or we can use any means. So we can communicate with any notary server which determine the validity and integrity of that received content. So it is just like a TLS way of doing the things here, which resembles very similarities between TLS and notary server, but it has some extra step because it do not rely only one keys. It creates some bunch of 3 keys out there. So we'll talk about that as well. Let's see how we can do that in action. So let me go to my terminal and see that. Okay, so we can first command is to generate the key, okay, because right now we are the signer, right? So we are actually signing our images. So for that I will use simply generate key. So I'm just giving it my name. You can give it any name, right, related to your repository, or any name basically you can give. So I'm going to give, because I already have that, so I'm utilizing that same generated key. And
So otherwise, you can zoom it here a little bit because it's very small text coming.
okay, is it visible now?
Yeah, this is fine.
Okay, cool. So okay, I'm going to run that command again. So we first need to generate the key for the signer, and we named it. So I'm utilizing my name, and I already did that. So it will create a public key here, right? So you can see here it's my public key with the role parameter here. So it will specific to notary server. Notary server, it will encode and decode it, so we don't need to worry about that. And then after that we can see our private key here as well. So we can see these keys are already there, but which is related to this public key. And okay, so we just created the key. Now we need to add the signer to this repository. So let me go through this one. So we have public key. Now we need to add that to the notary server. So as I said, Docker Hub already that notary server running. So when we run this command and we pass our public key and we call it any signer name, and we pass the repo. Okay, so the repo URL or whatever we pass here will decide where the notary server is. So by default, if we don't specify anything, it will take Docker Hub, right? So let me take that and show you. Tag. Tagging it again through. I'll just change the repository here. Let me see if it will work. Sorry for that. Yeah, I was actually entering the wrong repo. Okay, so now it actually asking for the passphrase. So when you do for the first time, it will create root key, it will create repository key. So basically root key is uh, the offline key which we use for setting up that authentication between your client and notary server, and then we have repository key which is basically used for signing the tags. So here I'm going to enter the passphrase for that. Don't worry about that. If you do, or if you run this command for the first time, it will simply ask you a passphrase, and remember that. For the next time, it will automatically do that and ask you. You can see, and now it is asking for the repository key. Okay. Okay. So yeah, because this is a new repository I'm adding, so that's what it's asking to set up the repository key. Okay, so we just initialize our signer to this particular repository. So if we go for signing the image, now let's start signing the image. Okay, what we have to do, we just have to go for docker trust sign and the repository or image name basically. So to do app latest, so we have this app tag. We need to define the tag because this latest tag going to be signed with this one. So it will behind the scene we know the signer related to this repo, so it will simply sign and pushing trust data for the local image, and it may override the trust data on to the repository, remote repository we would call it. Okay, there is one more thing. This is the one mode like where we manually need to say we can pull or push any unsigned image, or we can push what we call it sign and push the trusted one to the remote server. But if you want to enforce that only push and pull the signed image, for that case we have to utilize this environment variable where we enable docker content trust. So this will enforce that we cannot utilize any unsigned image. So let me do that, and I will show you. Okay, so for signing it will ask me the signer key. Okay, so it successfully signed that. Okay, so if I enable this one, so now we just enforce that we should be pulling or pushing the signed image to the Docker repository. And now we can see Docker. Okay, let me tag it again with a different tag and we'll see how it behaves, right? So here it is. I'm gonna tag it. Sorry. Okay, so if I try to push that to do app 01, we'll see while this one it will sign as well. So you can see signing and pushing the trust metadata. So we don't have to explicitly sign it, right? So once we say export this command or enable Docker container trust, all push and pull will do the content trust check. So it will ask me to enter the passphrase for the signer passphrase, and you can see. So we both have signed image here, right? Okay, so any questions on this one?
I guess good.
So, do we need to do this procedure for all time or only once, first time?
For
Like,
specific repository, we have to do it once,
mm,
right? Because I just
so
utilize one.
after this procedure, if I build again, so
Yes.
no need to do it again, right?
No, you don't have to do
Okay,
that.
okay.
You just have to, once you enable, but we have to enable it, right? Otherwise, we have to sign it explicitly because we are not enforcing it, right, to do so.
Yes. Good. Good.
Any question? Okay. Okay. Okay, I'm moving ahead now. It comes to image scanning, which is pretty much straightforward. Docker scan run on Sneak engine. Basically, it's a platform for security, and it has all the vulnerabilities list out in their servers, so that they can utilize the pattern to scan our images out there. So we have couple of thing, like it will only work on local system, so where we have installed that. We cannot have a remote scanning kind of thing. For that we have to go in other tooling, but for the default, if you were searching for the default scanning solution, so we already have. So let's see how that works. So we can see, so we have Docker scan, and we'll use our existing to do latest. Okay, so it will check the Sneak and find out, like, is there any vulnerable thing in that particular image, and it will also scan log4j, which we got to see last year, right, in November and December. So that also there. Okay, sorry for that. I have reached a scan limit for it. Okay. Okay, but I can show you the output as well. Let me go for that. Yeah, that's a drawback basically. So I just picked it up from the web, so you can see it will show like this one. So it will say all the dependency which we utilizing, it will check for that, and it will say us like low severity things are there, and then from where it's coming, right, which package, from which package it's coming, so we can track that as well, right? And if you want to see in tree manner, we can do docker scan, and we add the dependency tree as well, and it will show us a tree format for dependencies, right? And yeah, there is limitation for us, because as it shows here, it can exceed for 10 scans, authentication. So we have to go for sneak account. We can simply say purchase or anything. I guess they provide some free as well, so we can do so, and it will utilize that as well. Yeah, so let me go back and see what's saying. Okay, so there's one more thing. So this is one for base image. Let's say if you want to exclude the scanning of the base image which we have, let's say for the stretch one, if you don't want to scan this particular base image or this one, so we can simply say exclude base, and the image name which we are trying to scan. And yeah, to get a detailed scan, we need to say file and then docker file name here. And we already see that dependency tree is there, so like this one, so it will show us the tree of dependency. Yep, I guess this is it, I guess.
Cool.
Thank you everyone for joining us today.